Hello everyone, this is Abdul Rafi Islam, graduate student of Civil Engineering, Arkansas State University. Today I am going to give a presentation on life cycle cost estimation of corrugated metal pipes in Arkansas. This project was supervised by Dr. Jahid Hussain, Associate Professor of Civil Engineering, Arkansas State University. This the project outline includes introduction, background and motivation, objectives, methodology, results and discussion, conclusion and recommendation. Arkansas Department of Transportation frequently use corrugated metal culverts for the highway uh, sorry for the higher drainage system, and these metal culverts frequently subject to corrosion, and the corrosion mainly depends upon the types of metal used for the culverts, properties of bed materials, water quality and sediment passing through the culverts, abrasion offered by the sediment passing through the culvert, as well as temperature variation and the weather variation. And these are the parameters needs to be accounted while selecting the metal culverts for any region. And Arkansas Department of Transportation 2014, a standard specification for highway construction, doesn't have any documented guidelines such as considering all these parameters while selecting the metal culverts for this region. And in 2018, Arkansas Department of Transportation allocation was about 3.4 million for all pipe culverts, including concrete pipe culverts and corrugated steel pipe culverts. Even still, Arkansas Department of Transportation using metal corrugated pipes, even they are not cost effective. In order to find out cost effective and suitable metal culverts for this region, life cycle cost analysis is the best approach. In this study, a comparative life cycle cost analysis was done for choosing best type of metal culverts for this region. Objective of this study was to estimate the life cycle cost of three different types of metal culverts, such as galvanized steel pipe culverts, aluminized steel pipe culverts, and aluminum type 2 culverts. In order to estimate the life cycle cost of three different types of culverts, first thing is to analyze the inventory and collect service life data of culverts, collection of traffic data, and cost data associated with the different culverts. Then incorporate this traffic data to calculate the user delay cost, and then estimate the life cycle cost of different metal pipes, and finally recommend cost effective maintenance option. This is the methodology portion, which includes the literature review. Extensive literature review was conducted in order to find out the best or suitable approach to estimate the life cycle of three different types of um, metal culverts. This includes the collection of service life estimation data, collection of itemized unit cost data, a collection of traffic data, which is obtained from Arkansas Department of Transportation, collection of soil data such as resistivity data, pH value of soil. This was collected from the Soil Survey Geographic Database and University States Department of Agriculture, and a collection of water quality data, which was obtained from the Arkansas Department of Water Quality, and then calculate the service period of each type of metal culverts. After estimating the service period of each type of metal culvert, then estimate the life cycle of each type of metal culverts, and finally develop GS mapping. In order to estimate the life cycle cost of three different types of culvert, the following equation number one was used, and this equation was first used by Perrin and Jabari in 2004. And this equation is a function of initial installation cost, replacement cost, and user delay cost. And user delay cost is a function of average annual daily traffic, as well as number of installation required, average rate of person delay in dollars, average rate of freight delay in dollars, percent of passenger vehicle traffic, and percent of truck traffic. In this study, total 5% of truck traffic on the highway was considered. These are the steps. Primary steps is to gather the data of soil resistivity and pH value of soil, as well as the index property of soil, such as identification and classification of soil, as well as the pH value of soil. Total 16 samples were collected within the Arkansas, and this data was were trained in neural network models in order to predict the soil resistivity of other locations. Then estimated soil resistivity and pH value were then used to predict the service life of metal culvert based on Florida and California methods. And then estimated service life is then used to determine the life cycle cost of selected metal pipes using the equation 1, which was used by Perrin and Javeri in 2004. In order to estimate the life cycle cost of three different types of culvert, following data are required, such as traffic data, which were collected from Arkansas Department of Transportation or Arkansas GI office, a collection of itemized unit cost for different work items, and it was collected from Arkansas Department of Transportation contracts and consultant division, and then calculate the life cycle cost in a point-wise for three different types of culvert using the equation 1, and finally develop map using the ArcGIS. This is a summary of estimated service life of different metal culverts of Arkansas. This includes the service life of galvanized steel pipe, which was found maximum 50 years using the method of California 1999. Another one is aluminum type 2 culvert. Its estimated service life was found to be maximum 125.6 years, and it was found by using the Florida Department of Transportation method 2012. Another one is aluminized steel pipe or aluminized steel pipe, and its service life was estimated about maximum 204 years using the same method for Florida Department of Transportation 2012. This figure shows the traffic data for average annual daily traffic of the year of 2008. These data were collected from Arkansas Department of Transportation, and the values of average annual daily traffic ranging from 0 to 125,000, and higher the value of average annual daily traffic, bigger the diameter of the circle. This is the result and discussion part. This figure shows the spatial distribution of life cycle cost for galvanized steel pipe. This figure has been categorized into several sports, such as white sports and other colored sports. White sports has too low service period for galvanized steel pipe, and the life cycle cost for this white sport was not calculated since its estimated service period was too low compared to the colored one, and colored one has the higher life cycle cost for galvanized steel pipe. From this figure, it can be concluded that the installation of galvanized steel pipe within this zone is not feasible. This figure shows the spatial distribution of life cycle cost for aluminum type 2 steel pipe. This figure also has been categorized into several sports, such as white sports, blue sports, yellow sports to red one. Same as before, the white sport has too low service period for aluminum type 2 steel pipes, and the life cycle cost for white sport was not estimated since its estimated service period was too low compared to the colored one, and the blue one has the lowest life cycle cost compared to the yellow to red one. That means the installation of aluminum type 2 corrugated steel pipe is more feasible within the blue spots. This figure shows the spatial distribution of life cycle cost for corrugated aluminum pipes or aluminized steel pipe. This figure also has been categorized into several spots, blue to red one, and blue one has the lowest life cycle cost for corrugated steel pipes. That means the installation of corrugated aluminum pipes is more feasible within the blue areas or blue spots. This is the conclusion and recommendation part. The eastern part of Arkansas has comparatively lower life cycle cost for aluminized type 2 corrugated steel pipe and corrugated aluminum pipes. In case of galvanized steel pipe, the life cycle is exorbitant for most of the areas. Several counties such as Newton, Union, Washington, Logan are critical for metal pipes, and major precautions should be taken prior to the selection of any metal culverts in this region. That's it. Thank you all.
Great, thank you very much. So we have a few minutes for questions. Does anybody have a question? I guess I can start off with a question. So the analysis is very specific to Arkansas. How do you see this applying even broader across the rest of the country?
Okay, this is Zahid. Actually, Rafiu volunteered to help me to deliver this presentation. The motivation of this study came from Louisiana. There was a study done, and I was at a conference, and that time I saw this kind of map for Louisiana, and then from that study, it was reported that in New Orleans, even they banned to use metal pipes. So that, then I took this as a problem statement for Arkansas. Now, how we can expand this? Definitely, like we need to get some soil sample and test the soils, and then expand the neural network model for other places. Again, you have seen like some of the white spots in the maps. Like those spots, we did not have enough data to do the cost analysis. To expand those, even for those spots or in any other neighboring states or throughout the country, if we can gather more soil data and then run the neural network model to predict that resistivity at as many as a spot as we can, then this can be applied in other places.
Okay, thank you. Dependent upon soil data. Okay, thank you very much. Any other questions?